Okay, so hello, I'm Michael Widmaier. I'm a database analyst senior with the Ed Plus data analytics team, and I'm currently the lead developer on the Ed Plus Data Mart. And today I just wanted to share with you a few things that we're doing in Alteryx, or a few customizations, I should say, that we're doing in Alteryx to try and improve the efficiency of our Alteryx workflows so we don't bring down, we don't overtax the server. At the beginning of every quarter, I like to share just some fun numbers with everyone about where the Ed Plus Data Mart is and where it's going and where we've been. We started this project about 1.5 years ago with nothing. And today we've got over 800 tables in our data mart, over 800 gigabytes of data, and 170 workflows currently in Alteryx. Our team is the second highest utilizers of Alteryx. The DI analytics team is the only one higher up than us at the moment. In order to have such rapid growth with a project of this nature, you need to have two things, in my opinion. The ability to do fast data validation, and to have very efficient ETL workflows. And so yesterday we did a presentation on our data validation process, and today I'm going to walk you through what we've done in our workflows to improve performance. So if you think of how our data mart structure is, it follows the pretty standard data mart pyramid. We import all of our raw data, and then from there we begin aggregating it up until we can get to our final goal, the highest level, where we can actually then present that data to our users in either Tableau or whatever system we're using. And if you actually open up some of our Alteryx workflows, you can see that they follow that schema. Each one of these macros represents a table that we are transforming into, that we are extracting data from, transforming, and loading into another location. The first 4 or 5 macros on the far left are all coming from Redshift and loading into the Postgres AUDB database for us. And then everything else beyond that is what we actually transform off of those core 5 or 6 tables. We have about half of our workflows are structured like this. And this one is actually our slowest. It takes about 6 hours to run, but as you can see, it loads roughly 30 tables into the data mart for us. So I'm going to quickly go over some of the basic options for loading data into your data mart. This is pretty standard. All of our tables start out the same way. We download the data from, in this case, now Redshift. It was Oracle a month ago. And we do a minor transformation to it, and then we upload it using the standard Alteryx output of using the create table. Downloading, in this example, 1.95 million records from Redshift is very fast. It took less than 30 seconds. But to actually create the table takes roughly 2 hours. Not sure why, but for some reason a lot of users do like the simplicity of using the drop create feature in Alteryx, but that's just simply not sustainable for your long-term development needs. Approximately 6 months ago, Alteryx introduced the new Postgres bulk insert feature into our environment, which is much, much faster. It takes about 1 to 2 minutes to load those 1.9 million records into Postgres. The problem with the Postgres bulk insert, we're not using it with our data mart at this time. And the reason is simply because it seems to be hit or miss as to whether or not it actually works. If you're doing the standard drop create with it, it works 100% of the time. But if you have any type of doing anything else, any type of appending of the data, if you have a constraint on that data, whether it's an index, primary key, or just simply another workflow that is pulling data out of that table at that time, the insert will crash. And so at this point, we don't think it's stable enough to be used in our workflow, but we are working on making it more stable, finding ways to make it better. Also, it was only added 6 months ago, and our data mart's been around for over a year. And so we had to, a year ago, it wasn't even an option to use the Postgres bulk insert. And so we had to find a more stable way, a stable and fast way to get data into our data mart. Well, if you're not going to use the drop create feature, or if you're not going to use the standard create table feature, and you're not going to use the Postgres bulk insert, the only other option you have is to do an upsert. The upsert option by itself is also extremely slow in Alteryx. It will take easily more than 2 hours to load 1.9 million records. And the reason for this is because what Alteryx is actually doing is it's taking those records, chunking them into loads of approximately 10,000 records, checking in the database to see if it needs to be an insert or an update, and then splitting it out in 2 separate paths. And so it could literally take all day just to do this one simple workflow. So we came up with the concept of splitting out the inserts and the updates with a differential checker. And so what we're doing now is we take our source data, we take our destination data, and we compare it to see if there are any differentials, and then just push the differentials into the upsert. This reduces the payload greatly, and depending on the table, it'll easily reduce it by 80 to 90%. By pushing in just the differentials, we're able to speed this entire workflow up down to roughly 30 minutes. But still, it could be better. You might think in this situation, it would be better to use the transpose tool instead of doing the join, but I found that the transpose tool, when using a large volume of data, will actually overload your BI desktop's memory very quickly. And so doing the join was actually more efficient, though it is a lot more time consuming to set up. The other problem with doing this is, what do you do if you actually have to delete records? In order to delete records, we have to add an additional step. We can first join the source data and the destination together by its primary key and split out the records that actually do need to be deleted. From there, you write a custom delete query and you push that into your output connector's PostSQL command. In order to do PostSQL commands dynamically in Alteryx, you first have to wrap the output up into its own batch macro, which adds another layer of complexity that we had to do as well. Now, doing it this way, there is a limit to how many records you can delete. You can only delete roughly 100,000 records at a time. Anything greater than that, and you actually will overload the output connector. I don't consider that a problem though, because if you're deleting more than 100,000 records at a time, you probably need to rewrite your workflow. And just for fun, I like to add timestamps to everything. So I went ahead and added a create and an update timestamp to this workflow. Now, if you ever find yourself doing something repetitive in Alteryx, well, turn it into a macro, parameterize it and turn it into a macro. And so that's what we did. We created a custom Upsert output tool specifically for our data mart. You add the destination data, you list out what the primary keys are and what fields you want to compare to. And this program will actually do that differential comparison for you and push the data in. We also added the feature to delete records and to add a custom filter onto your deletion and to your differential comparison. The reason for this is another great way to improve performance is to limit the amount of data you're sending to the Upsert. And so I keep mentioning that this example has 1.9 million records in it. Most records that are being inserted, only about 2 or 3% of those are actually changing. Most of those records are old and aren't needed. And so by adding a where clause to our source of only limiting the data down to the last 3 semesters, and then adding that same where clause onto the Upsert macro, we can reduce the amount of data that we're pulling down from Redshift and reduce the amount of comparisons we have to do for pushing into Postgres. Of course, whenever you build a macro, things just get complicated. You have to add a lot more steps for each of the parameters and a lot more processing. But in the end, I think it's worth it. Future projects that I'm working on. is trying to incorporate the Postgres bulk insert into this process. We have one of our workflows that runs, pulls down 193 million records from Redshift and updates approximately 300,000 a day. So a massive amount of data is being pushed back and forth. What I want to do is I want to take those 193 million records, split them out the same way I was doing so I get the differentials. But from there, take the new records, because most of the time it's only new stuff that's being created. We have very few updates. Push that through the Postgres bulk output, and then push the remaining records through the standard Upsert, so that we can actually get the best of both worlds, have the performance of Postgres, the bulk insert option, while at the same time using the differential comparison to reduce the payload to its bare bones minimum. Beyond that, we have a lot of other output tools that we work on that I'm just going to briefly mention to try and improve performance of Alteryx. Our Salesforce team, I think this is common with most Salesforce teams, they love adding new columns to their tables. And we need to get those automatically added to our data mart as soon as they're created. Well, the only way to do that would be to download the whole table and drop and create the table nightly. With Salesforce, you're talking about 2 or 3 million records, and the Salesforce API by its very nature is very slow. And so there's really no efficient way to do that without limiting the amount of data that you're pulling in. And so what we did is we created a dynamic column output. So we pulled, once again, just records that have been altered in the last few days from Salesforce, which reduces our payload. And then we push that through an Upsert. But on top of that, before we push it through the Upsert, we compare the data schema of the table to see if there are any new columns added since the last upload, and then add those columns to the table dynamically first, and then push in the data. This gets us the best of both worlds. We're able to dynamically add new columns as they're being created with the Salesforce team, while at the same time limiting the payload down to only records that have been modified in the last few days. Another thing we do, and this isn't really related to the data mart as much as it's related to other projects. In addition to the data mart being built for reports, we also have to SFTP a lot of files out to third parties. And we found that to do that through Alteryx, there's simply no standard tool for that. And so we created a custom SFTP output macro just so that we can push those data files over. In order to do this, we actually had to create a custom custom Python script and have UTO install actually custom packages on the server in order for that to work. So that's the bulk of the development we currently have that we've done this currently. And so I thought it'd be fun just to kind of go over some miscellaneous items that we've seen with Alteryx that hurt your server, your data throughput. The first up is the data cleansing tool. So this is a simple tool in Alteryx that you can attach to any workflow that has several features. Allows you to remove null rows. It allows you to replace any nulls with blanks. You can do a modify case across multiple columns. It's a very easy, very handy tool. Just don't use it. The problem with the data cleansing tool is that the workflow behind it is excessively complex. And so what we found, if all you're trying to do is convert a couple of columns, all the nulls to blank, if you use the data cleanse tool, it'll take 4 or 5 times longer than if you were to just manually create the formula yourself using a multi-field formula tool. And so we do not use the data cleansing tool at all in our workflows. Another tool would be any of the InDb tools, and we do not use them. I don't let them on my network if I can avoid them. The problem with the InDb tools is that what they're trying to do is they take a workflow, they convert it into SQL, and then they run that SQL against the server for you. And the challenge with that is how we tend to lay out data workflows is different than how we write SQL. And so when you use the InDb tool, you tend to create, the SQL tends to be overly complex. The example I have here only includes 2 tables. So the database engine compiler would probably be fine. It could find the best path for pulling up this data. But as you add more tables and more joins, the complexity with InDb just grows, and the probability of the compiler finding a bad execution plan grows exponentially. And so we just don't use it at all. Another minor thing to think about is using select, join, and filters in Alteryx. These are nice, simple, easy to use tools that also can make workflows very inefficient if done incorrectly. If you can push, you should push all of your joining, selecting, and filtering down to your SQL level if you can. And so by pushing it down to into your input tool, you will actually use less resources overall. A couple other things we've noticed is the Salesforce Input tool is problematic. We currently have 2 input tools floating around here at ASU. We have one that is a Python-based tool, and the other input tool, which is a workflow-based tool. Last year, there was a bug in the Alteryx server, not related to our installation. It was actually on the Alteryx developer side, where the Python tool would not work in the Alteryx gallery. You could use it in Designer, but if you uploaded anything to Gallery, it would fail. And so we encouraged everyone at that time to switch to the workflow version. Now our server's been upgraded to a newer version, 2020.3, and 2020.3 can in fact use the Python tool. So now I'm trying to encourage everybody to dump the old tool and move to the Python one. The Python workflow is about 2 to 3 times faster than the workflow version. This is because the workflow, how Alteryx parses out the JSON packages, if you're interested to know, from Salesforce, the workflow one is just much slower doing that. The downside to the Python version is you have to install it yourself. The workflow one is in your designer by default. This new one, you have to go to gallery.alteryx.com and download it in order to use it. You also must make sure you're using the right version. There are multiple versions of the Python tool. The version we have on the gallery is version 3.1. Version 4 will not work on our gallery. But if you get it installed and you get the right version, it does have some new features on it, and it's a lot faster to use. So future projects. We were talking about doing, if anyone's interested in doing like a hackathon, we've got a couple of items that we are working on, we would like to do. The first is the S3 output tool. The S3 output tool in Alteryx cannot process any file greater than 5 gigabytes. This is because Amazon S3 requires that any file greater than 5 gigabytes be chunked into smaller payloads and sent over asynchronously. The current S3 output tool cannot do that, and so it has a 5 gigabyte cap on it. Fun fact, when we stumbled upon this error, our workflow started failing at 3 gigabytes, not 5. And the reason is because Alteryx likes to take data and convert it to blob data types, which take up a lot more memory than your standard CSV. And so actually when I say files over 5 gigabytes, it could be sooner. You could crash sooner if, depending on the workflow and depending on how the data is being prepared. Another project that we were working on was creating a GCS output tool. By default, there is not one in Alteryx. So I went online and I did find someone who had created one and downloaded it, and it was dead on arrival. did not work at all. So we passed the project over to a student worker who took a shot at it for a couple of weeks and made several improvements to it. The big downside she ran into before she left, she said there were two major flaws with it. The first was it cannot accept files over half a gigabyte. If you try to send a file over half a gigabyte, it will fail. And so that's one limitation that we need to still work on. And then the others, it will not accept raw data. You have to pass in the path and file name and have it upload from your local machine in order for it to send data. That's not going to work on our Alteryx gallery. So we need to get it to accept raw data. And then at that point, this project got put on the back burner because we found a workaround for getting data into GCS. But if anyone is interested, that's another project that we have on the to-do list.
So thank you so much for joining us, and have a great rest of your day. Thank you, Mike.
Thank you.